Today we're going to continue looking at section 5.5. We're going to find missing values using properties of any of the quadrilaterals that we've been looking at. So let's start with this example here. I'm giving us that MATH is a rectangle, and I'm also telling us that the length of MT, which if we notice looks like it's a diagonal, that diagonal is 36 inches. So if we're talking about diagonals, one thing that I know is that take those two little pieces and add them together, and it's the length of MT, which we have. So 2x plus 4y plus 4x minus y is going to equal 36. But that one equation is not going to get us x and y because they're two variables in the same equation. So we do have to set up a system. So because a rectangle is a parallelogram, I know that diagonals bisect each other, which means that ME and ET are going to have to be congruent. So that's my second equation. 2x plus 4y is going to equal 4x minus y. So I'm going to set it up to do elimination. I noticed that I've got some like terms in the numerator. I keep saying that. Numerator is not a thing because we don't have a fraction. The top equation. And then in the bottom, I'm going to move everything over to the left so I can get all the variables to the same side. So once I do that, looks like the top equation now is going to be 6x plus 3y, and that equals 36. In the bottom, we're going to have negative 2x plus 5y, and that's going to equal 0 because once again, we moved everything over to the left. There were no just constants, so it's 0. As you can see, I can very easily manipulate that bottom equation because if I multiply that negative 2 by 3, it's going to turn to negative 6, and then I'll have my opposites where I can then eliminate the x's. So the top equation did not change. 6x plus 3y is still going to equal 36. But now when I multiply 3 throughout that bottom equation, we get negative 6x plus 15y to equal 0. So when I add up my columns, we're then going to have 18y equals 36. So divide both sides by 18, and we'll get one of our answers. Looks like y is going to be 2. So now I have a lot of different equations. I can plug that y value of 2 into like any of these equations. I think I'm going to go back to the equation where I have like the smallest numbers. So that would be the negative 2x plus 5y equals 0. So notice that I can multiply 5 and 2 together to give me 10. I can subtract the 10 over to the other side. So negative 2x is going to equal negative 10. And then I'll divide both sides by negative 2. So it looks like 5 is my other answer. All right, let's talk about parallelograms. So I'm going to mark up everything that I know from this given information. Angle M is x plus 3y. Angle O is x minus 4. Angle P is 4y minus 8. Because we're talking about a parallelogram, we have 5 properties. But because everything that's given is dealing with angles, there's 2 specific properties that we can focus on. Opposite angles are congruent, consecutive angles are supplementary. So notice that in this, angle M and angle P, those are opposite. So x plus 3y is going to equal 4y minus 8. We actually have 2 different sets of consecutive angles here. M and O are right next to each other. O and P are right next to each other. So it doesn't matter which set of consecutive angles you pick. I think I'm going to pick M and O. So x plus 3y plus x minus 4 is going to equal 180. So now I'm going to manipulate these equations to get x's and y's to the same side. So in the top, all I have to do is subtract the 4y. And then in the bottom, we've got the x's that we can combine, but I do want to move that 4 over to the right. So it looks like my top equation is now going to be x minus y, and that equals negative 8. And my bottom equation is 2x plus 3y and that equals 184. So I think I'm going to eliminate the y's because I already have opposite signs. I can just very easily change that -1 on the top to a -3 by multiplying the entire top equation by 3. So my new equation is going to be 3x minus 3y equals -24. Bottom equation is still the same, 2x plus 3y equals 184. Now I can add these up because the y's are going to cancel. We'll just have 5x to equal, what is that, 160. And 160 divided by 5 is going to give us a value of x to be 32. Okay, so the problem didn't ask for x, it's asking for the measure of angle K. So we could stop here. Like I could solve for y, and then there's a lot of different options that we could do. But to find the measure of angle K, I noticed that it is opposite angle O. Angle O has an expression with just an x. So that's why once I solve for x, I'm actually good to find my answer. But if you did solve for y, that's perfectly fine. If you solved for y, what you could have done is you could have plugged in that value of y for angle P, and then you would have had consecutive angles because K and P are consecutive, and then you could have subtracted that from 180. Or the same idea, you could have plugged X and Y in for M, and then you had consecutive angles, and you can find the measure of angle K. But, I mean, plugging in X for angle O and then having the answer right away is going to be the fastest method. So the measure of angle O is going to be 32 minus 4, which is going to give us a 28-degree angle. And once again, opposite angles are congruent, so that is also the measure of angle K, which is what this problem was asking for. So we're done. All right, here I'm giving us an isosceles trapezoid, upper base of AD. So remember, bases are the parallel sides, and if we're talking about an isosceles trapezoid, we technically then have those two legs, AB and DC. All right, I'm going to mark up what I know. I know that BE is a length of x plus 7. I know that CE is y minus 3. I know that AE is x plus 5. And I know that BD, which is the entire diagonal here, is y plus 4. All right, so because I have the length of an entire diagonal, I know that diagonals in an isosceles trapezoid are congruent. So the other diagonal is AC. Well, that's two smaller pieces. That was AE and EC, but I can add those two pieces together and set it equal to that length of the entire diagonal BD. So there's my first equation. So once again, diagonals are congruent. However, because this has both x and y, we are going to have to come up with a second equation. So this is where we have to kind of understand the properties of an isosceles trapezoid and actually think back to chapter 3 when we were proving congruent triangles. So I actually want us to focus on this triangle of ABD, and I want us to focus on the triangle of ADC. Those two triangles are actually congruent to each other. And the reason why they are congruent is because I know that I have AB congruent to CD because those are the legs. I have the same side that is in both the triangles, so AD is congruent to itself by the reflexive property. And I do have diagonals that are the other side, so AC and BD, so those are congruent. So technically I have these triangles congruent. So triangle ADC is congruent to the triangle of ADC, so I have to say DAB. So those are congruent because of side, side, side. And so when those sides are congruent, then anything else is congruent. So essentially then I can say that this angle of angle ADB is congruent to the angle of DAC. And if I know that those are congruent, I know then that if I look at that I know I'm doing a lot of highlighting here, so let me erase the triangles that I highlighted. If I look at then the fact that those two little angles are congruent, and I look at this triangle of ADE, I have two angles congruent. So that means if those two angles are congruent, then the sides are congruent. So I know that this side and this side are congruent. So if AE is congruent to DE, that actually means that BE and EC are congruent. And that's because if the whole diagonals are congruent, I could subtract those little pieces and get the other piece. So that was a lot of information, but regardless, since I know that BE and CE are congruent, I actually get to set those equal. So x plus 7 is going to equal y minus 3. All right, so now I have my two equations, and now I can start solving. So I'm going to fix the top equation where I'm going to subtract an x, subtract a y, and I'm going to subtract the 4. And then in the bottom, I can subtract the y and subtract the 7. Oops, that's not what I wanted. All right, so if I look at the top, actually, if you look at the top, the y's are going to cancel out. So that really gives us a negative x to equal, then we have 5 minus 3 minus 4. So that's going to give us a negative 2. So right off the bat, we actually can solve for x. We can divide by 1, so x equals 2. So I technically then really didn't even have to manipulate that bottom equation, because once I get x to be 2, I can substitute 2 in, so I can kind of ignore this work for a second. And if I plug 2 in for x, I'll have 2 plus 7 equals y minus 3. So that gives me 9 equals y minus 3. I'll add 3, and that gives me then y to equal 12. And so if they want me to find AC, AC is me adding x plus 5 plus y minus 3. Well, now I know that x is 2 and y is 12. So 2 plus 5 is 7. 7 plus 12 is going to give me 19. And then I'm going to subtract 3. And that's going to give me AC to be a length of 16. All right, I would suggest that you pause the video and try this checkpoint problem given a rectangle and given the measure of two angles. Find x and y. All right, since both of those were angles of a rectangle, we know that those are right angles. So I have two equations that then equal 90. I was able to do elimination, get x to be 18 and y to be negative 6. So that's us finding the missing values using properties of any of our quadrilaterals.